Let me explain about the effect of dielectrics in a capacitor. Let me consider a capacitor like this. Capacitor is nothing but parallel plates. There are two plates and they are charged. Now one of them is charged. Here, this is the capacitor. I am introducing some mica or any insulation material. So what we are going to discuss is, by introducing this dielectric and insulation medium, the capacitance increases. So this is the concept we are going to discuss. So for which we are having two aspects. One is, that is capacitance, that is capacitor without connection to the battery. The another aspect is capacitance with connection to the battery. So the capacitance is disconnected from the battery, no battery, whereas capacitor is connected to the battery. So likewise we can classify this. Now let me explain about the capacitance without battery connection. So these are the two plates. You have got positive charge, you have got negative charge, and from the positive plates the electric field is available here. The direction of electric field is here, and this is represented as E vector. The distance between the two electrodes, this is D. Now we know the basic formula of capacitance, which is nothing but the ratio between Q and V. Now we are talking about the capacitance without dielectric, so that is represented as C naught, and charge without dielectric, Q naught. V naught represents the potential difference without the dielectric. So based on this, now we can proceed with the introduction of dielectric. When we introduce this dielectric field, dielectric constant or dielectric medium, what occurs? The electric field decreases. How? Because this electric field is equal to E naught divided by epsilon R. Okay? So this epsilon R is nothing but dielectric constant or relative permittivity of certain medium. So E naught is the electric field without dielectric, whereas E is electric field with the dielectric. So in this case, by introducing a dielectric, the electric field decreases. Do you agree with me? Right. Now let me have this equation. Potential is given as the product of electric field and the distance between the two electrodes. So this E can be given as E naught divided by epsilon R. So I am replacing this. Now we have got epsilon naught divided by epsilon R into D. And this is nothing but V naught. So we can put V naught, and because E naught D is equal to V naught, as we are claiming here, V is equal to E into D. V naught is equal to E naught into D. So E naught into D can be represented as V naught. Therefore V is equal to V naught divided by epsilon R. Okay. So in this case, that is, we already know the capacitance is always inversely proportional to V. Why? Because we know C is equal to Q by V. When charge is constant, this is inversely proportional to V. Is it not? So C is inversely proportional to V means what? When V decreases, C increases. Okay. So C is inversely proportional to the potential difference. Okay. So when this relative permittivity, okay, when this, let me come here. C is equal to Q naught by V. Is it not? So from this, C is equal to this Q naught by V naught. Is it not? Q naught by V naught. Okay. So which is nothing but how I have arrived at, that is C is equal to Q naught by V, and Q naught by V naught. How we get it? Can you explain? So V is equal to V naught by epsilon R. So I have reciprocated. So Q naught by V naught into epsilon R. So Q naught by V naught is nothing but C naught. Therefore C is equal to C naught into epsilon R. So from this it's pretty clear that when epsilon R is greater than 1, what happens? C is greater than C naught. What do you mean by C naught? The capacitance without a dielectric. C is the capacitance with the dielectric. So what does it imply? It implies that by introducing dielectric, an insulation medium, what occurs? The capacitance increases. So this is what we want to establish, and that I already explained at the outset. Okay. So epsilon R is equal to, what is that? Epsilon by epsilon naught. Therefore, epsilon is nothing but, that is epsilon R into epsilon naught. Do you understand this? Epsilon naught into epsilon R. So what is epsilon? Epsilon is nothing but the permittivity through certain medium, whereas epsilon R relative permittivity, and epsilon naught is permittivity through certain free space, that is vacuum. Okay, right, please note down. Now let me proceed further. We have got already this equation, that is C is equal to A into epsilon divided by what? The distance. And we already know epsilon is nothing but epsilon naught into epsilon R. So we can substitute. So capacitance is equal to A into epsilon naught into epsilon R divided by T. Okay. So what is this A? A is nothing but the what? The area of that plate. Okay. And epsilon naught, that is the permittivity through vacuum, and epsilon R relative permittivity. D is the distance between the plates. Therefore, by increasing the area, you can increase the capacitance. By increasing relative permittivity, it means what? By introducing an insulation medium, you can increase the capacitance. By decreasing the distance between the plates, we can increase the capacitance. So these are the possible ways of increasing the capacitance. Okay.